Hey, who else got up here? And Carrie. And who else? Jay Will. And who else? Kiana. You tried. Total don't lie. Look at me in my face. You grinning, you lying. He's always grinning. It's not.
Really funny. You made me laugh.
That's a lie. That's a lie. Here we go. Write this down. We're taking some notes.
Oh,
yes. Shut up. It is 11:18. Dean LaRue, you thought you were going to get by with not taking your notes. Ha-ha.
The math one my brain's full.
It is not, then you need to purge some files, honey.
Same thing.
I just referenced this just a moment ago.
Then slope equals 0.
If the functions have a horizontal tangent line, then the slope is equal to 0. Right on. I'm not getting it. So mathematically, what you're going to have to do, hey, how do I know what the slope is? What did KJ say the slope was?
The derivative.
The derivative. So if I want to know what the slope, if the slope is 0, then I don't want to set the slope equal to 0. I want to set what equal to 0?
The equation.
The what?
The derivative.
The derivative. Right. I want to set the derivative equal to 0. Okay? If the functions have horizontal tangent lines, then the slope is equal to 0, which means in our head, we go down another path and we say, okay, we're setting the derivative, which is the slope equal to 0. Here we go. Let's look at this example. Oh, my mercy.
Mercy.
Oh, my goodness. Look at you.
Is that the square root of 3 times x?
It is. The number, the square root of 3, it's about 1.7, y'all.
Roundabout.
Uh-huh. It is roundabout. As a matter of fact. So here's what we've got to figure out. We have to figure out where horizontal lines occur. Okay? Where do horizontal lines occur? We're going to find, because we have our function, which looks really weird, the square root of 3x plus 2 cosine x. Somewhere on that curve, on that function, there are going to be maybe 1 or 2 or 3, or I don't know how many, horizontal tangent lines. Okay? So if we're talking about a horizontal tangent line, then what do we have to do? What do we first have to do straight off the bat? We got to find the derivative. Okay? If we're talking about horizontal tangent lines, let's throw that in there too. My bad. Okay, I got to find where do the horizontal tangent lines occur. So I got to find the derivative. Y prime. What is the derivative of square root of 3x?
Wouldn't it be
X
x?
to the most power.
It's just root 3. Just a square root of 3. And then, what's the derivative of 2 cosine x? Okay, hold on. I need you to talk to the partner. You got to ask somebody in front of you, behind you. Every person better ask somebody. You better ask them first to make sure. Double check everybody in this room. Okay. Here we go, here we go, here we go.
No, it'd be minus 2 sine 1. No. You have to. No, okay.
Holly, what is it?
Minus 2 sine.
It is. Do you guys agree? If you agree with Holly, -2 cosine x, I need you to go, mm-hmm. Y'all are. It is, see? Should have done it. Don't let me make those mistakes. I did that on purpose though. Way to go, guys. Way to go. You called it, that's kind of class. Totally did that on purpose. And you did very well with that. Where do the horizontal tangent lines occur? I don't even know what to do. Talk to the person next to you and just ask. Just ask them. I don't want to know. Don't tell me. No, I don't want to know. Shut up! Okay, let's come back up here. Come on, come on, come on. So what am I going to do? Set that thing equal to 0. Set what equal to 0? The derivative. Why?
Because he said so.
Shut, that is not a valid answer right now. That's not.
So you have to set the derivative equal to 0.
Why?
To find the horizontal tangent line.
Because we got to find the horizontal tangent line. I don't care about a tangent line that passes through point blah, blah. I want the tangent line that's horizontal. I'm looking for something specific. Yes! Yes! So, what do I do?
Solve it.
How do we solve it? Did somebody say calculator? That is not a good answer. Never a good answer. Hey, what do you think? What do we have to get by itself?
X.
Okay, so what do I need to do? All right. I'm just doing what you're telling me.
I agree with you.
Well, can I divide by something else?
-2.
Why?
Which can?
Let's just do that right there.
No, I'm gonna take it with it.
What is that, Bria? What's a negative divided by a negative? Oh, I just saw some. Your spotty senses just went.
That's one.
That's what I was saying.
Shut up! Nuh-uh!
Yeah.
What? Girl!
Whoa.
Mind blown. Because you remembered it. Remember how you spell that. What is, I don't know what to do. DB said it's just, all right, first let's think. I got sine and I got what? Cosine. All right, which one is first?
Time is it?
Cosine.
Oh, wait.
Oh, cosine's first, sine's second, and this is a positive. Is it just going to be up here in the first quadrant?
No. It's gonna be.
It's going to be in multiple, but which ones?
The first two.
The third? You mean I can throw this thing down here?
Yeah, because you have the reciprocal.
Oh, well, where do I put that?
It's first and second.
First and second, zero.
Yeah.
Are you sure? Oh, Lord, it's at 11:27. Here's what you got to do for me. You got to decide. You got to decide for homework, where's that other angle? There's one other angle. Okay? There is one other angle. You've got to decide where it is. Where it be. Is it in quadrant 2, 3, or 4? 2. Shut. You don't know that for sure.
All stars.
La 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 la. Shut.
But we're all.
Shalala. Yeah. Hold on. I want you to figure that. Oh no, you know that ain't. You crazy. You crazy. Here's what you are going to do for me though. Okay? Because you got to finish. You got to try to finish this. We're going to pick up with this tomorrow. Okay? There is another angle, but we got to figure out where it is. And then just don't tell me it's over there. It's right there. I need to know what angle that ordered pair is connected to.
Ready.
No, degrees are the devil, just like decimals, because they all start with the letter D. Here's what I do want you to do. Check this out. Check it out. Check it out. Check it out. Check it out. I mean, because, you know, Dee LaRue, you're back. We got to make sure you're good.
Come on.
Yeah.
Good. Close it off. Very close it off.
Come on, let's
Hold up.
Yeah, keep going.
Yeah, keep going.
Come on now, baby.
Take out 71.
That's all you got.
We've already did 57 and 58.
You did not.
Yeah, we
Yeah, we did.
You did
Say
too.
it ain't so.
It ain't so.
You lie.
How about that?
That's all right.
We can do that right there.
Keep going.
Go ahead. That's what you got. We're gonna go over that tomorrow because I'm gonna blow you up with derivatives on Thursday.
Yeah.
Front. Front, get out of my face. Hey, look, before you leave. I know, but I'll just check it out.
But yeah, close like that.
Get out of here. Okay, so this is at the tail end. Start the video at 11:07. I will put that in my notes.
So you're just gonna go really fast?
I'll just go over. And if everybody else just has to do that. So for 27, it's y equals 5 over 2x squared. And we are told that we have to find the derivative, okay?
Was this a homework from last night?
It is. All right, so if that's the function, then I want to be able to use the power rule. I cannot use the power rule the way it's written. So I'm going to take that and I'm going to move it up to the top. When I move that term to the top, it's going to become x to the negative 2 power. Do you agree with that? Okay, so I'm going to take the negative 2 and I'm going to move it to the front and I'm going to multiply. Now look what happens. What happens to these 2's?
They can cross it out.
They can't cross out. Okay? So negative 1 times 5 is negative 5x. And when I lower negative 2 by 1, what do you get? Negative 3. All right, that's fine and it is correct, but it's better if I write it like that.
How did the 5 become negative again?
Because it's negative 1
Also, you
Times 5. multiply straight across. Does that help? All right, so that was 27. Did you say you need to say 30? Okay. 30. All you're doing is finding the derivative of this one too. First thing I would do is I'd have to simplify it because it's weird the way it's written. So we've got pi over. What do you do when you have quantity squared? What do you do?
You distribute it.
Distribute the power, so it's 5 squared is 25. X squared is, of course, x squared. And then what?
Take the x squared to the top.
Yep. And what will I write?
X to the negative.
X to the negative 2. All right, now go. Tell me what to do. Will you come up here and do it, and I will take notes on your paper. Okay, don't think of pi as just a symbol that represents a number. So it's going to be negative 2 pi over 25, which is fine. And then x, you lower that power by 1. What's it? X to the what?
3.
By negative 3 power.
And
So then I have to rewrite it again.
in the middle of the video, doing some graph.
What am I going to do?
2 pi over 25 x to the 3.
25 x to the third. I'm recording. Okay? So that's the best answer you can give me, right?
Yeah.
You cool with that one?
Yeah.
Yeah? All right, here we go. You ready? We're going to find the derivative. How do I find the derivative of sine?
South Carolina.
Yep. Okay, South Carolina. So it's going to be 4 cosine theta. All right, look. Theta is x. So it's -1, isn't it? Okay. Okay. Now, the instructions said, hold on. The instructions said, the fact that I go to this and not my textbook is absolutely crazy. 37. 37.
I think it says something else.
It says find the slope of the graph of the function at the given point. For 37, you are given the origin.
So you just plug in 0 where the theta is?
You plug 0 in for the theta, okay? So it's going to be 4 times the cosine of 0. Because, look, that 0, 0 is theta f of theta. Since we're not dealing with x's and y's, we're dealing with thetas and f of thetas, okay? Excuse me. Now, what's cosine 0? Where's 0?
And 0.
Where's the angle 0? Up, down, left, right.
Right.
It's right here. What's that ordered pair?
And like 1, 0.
1, 0. Which one's cosine, which one's sine? Cosine is 1, sine is 0. So what's the cosine of 0? 1. So you got 4 times 1 minus 1. 4 minus 1, which is 3. Remember that the derivative is the slope. The slope is the derivative. Okay?
When you're talking about 0, we're talking about
The angle,
The
the
circle
unit
thing
circle angle 0, yes. All right, now, the instructions say find the slope, we did. And then it says use the derivative feature of the graph, and no, we're not doing that. So all you would have to have was f prime of theta equals 3, m equals 3, the slope of f of theta is 3 at 0, 0. That would be the best way to write that answer. Okay? All right, let's look at 45. Easy. Can you use the power rule on that right now? The way it's written.
I didn't think so.
You
Okay,
can't.
I think you can, but I don't know how. Like,
Well-
I thought you could distribute that.
You got to simplify it first. Remember, this power rule has to be used on a monomial or a series of monomials in a polynomial. That's a rational function. The way I get it to the form that I want it is by just unsmushing. What'd you say? Take each term in the numerator and put it over, because look, when you add and subtract fractions, don't they all have to have the same denominator?
Yeah.
All right, so then simplify. What's x cubed divided by x squared? Where does it go, top or bottom? Top. What's 3x squared divided by x squared?
3.
What's 4 over x squared? It's 4 over x squared. But for derivative purposes, how do I need to write that function? 4x to the negative 2. Can you find the derivative of that polynomial function? Sure. What is it? Talk to me.
1.
1.
0. Minus 8. X to the negative 3.
Yep. And then simplify.
You don't have to show that there's a 0 there, right? I'll never do that part.
No, you don't have to, but you can clean even that up. How would you?
X to the negative 3, I'm going
Wait a
to
minute.
make it a positive 3.
1 minus 8 over
X
x
to
to
the
the
third.
third. There you go. Boom. That's the derivative. And then for that problem, that's all you have to do. This is acceptable. This is even better. That's fine. All right, let's Alright, now look, the instructions for this one, 60. Says find an equation of the tangent line to the graph at the given point. Okay, you ready? Alright, so what do we have to find? We got to find the slope, the equation of the tangent line, then I have to do what with this first? Wow. Calm down.
Cosine T minus 1/2
I got to find the derivative, which is, one more time?
cosine T minus 1/2 B to the
Yeah, okay. That's the derivative,
So then,
which gives you your slope equation, if you will. You'll think about it that way. Now, how am I going to find the slope at that point, pi 1/2 e to the pi?
plug in
What do these represent? What's pi represent?
T. T and F and T.
Yeah, that girl. All right, so what are you going to plug in?
Pi.
All right,
to the
so
T.
cosine of pi minus 1/2 e to the pi. Do you see how that looks funky?
Yeah, yeah.
All right, now, can you simplify part of that?
The
What? Can you
cosine of pi.
cosine of pi? All right, now, unit circle, where's pi? Up, down, left, right.
Plus
What's that ordered pair?
0, 1. Negative 1, 0.
What do we want, cosine or sine?
Cosine, which is negative 1.
Negative 1. So now, the slope is negative 1 minus 1/2 e to the pi, and that is the slope at t equals pi. That's your slope. Okay? It looks funky. We have to write the equation. Now watch. So y minus, what's y sub 1?
1/2 e to the pi.
What's your slope?
1 minus 1/2 e to
Times x minus what?
the pi.
Pi. If you can do that problem, 57 is going to be like arithmetic to you. But that's what you have to do. So what is this? This is the equation of the tangent line to f of t at, what was it, pi 1/2 e to the pi?
I thought you was doing number 57, so I was like, how is she getting this? I was
It's
like,
number
I didn't
60.
get that.
It's number 60. If you can do this one, you can go back to 57, piece of paper. What do you think about that?
Figured out what I did wrong on the daily quiz. I forgot to include the negative 2/8.
Okay, now, can I use the power rule on that problem?
Yeah.
Written the way it's written?
I mean, can't you simplify and make the x to 3/4? Or is it 3/4?
What kind of 3/4? It would be like this right here. Hold on.
X. Yeah, right there.
Okay, but can I use the power rule the way that's written right now?
Can you take it to the top?
I can take it to the top, and that's the only way I can use the power rule.
Mm-hmm.
So I'm going to rewrite it again as what?
2x 3/4? No.
Yes, you do. Move it. What's going to happen?
Negative 3/4.
There we go.
My bad, I forgot about the negative.
Okay. Now, find the derivative. The derivative is just going to give us the what? What's the derivative going to give us? It's going to give us the slope equation so that we can plug in and find the slope. Okay? So, how are you going to find the derivative of 2x to the negative 3/4? What are you going to do?
Times
Negative 3/4 times what?
2.
2/1. Is that okay if I do that?
Mm-hmm.
Why? Why?
Convenient.
It is a convenient. It makes a fraction. and I want to multiply a fraction to a fraction. So then x, how do I lower negative 3/4 by 1? What do I subtract from it? 4/4. Because they have to have like denominators. So what's that exponent going to be? Holy moly.
Negative 6. Negative 6 is 7.
Negative 7
7.
fourths.
Oh, because we're already lowering it down. Y'all skip this step. My bad.
Okay,
I was still.
right? Are we cool? Now, got to clean this up. What's that going to be?
-3/2.
All right, 2 goes into 2 one time. 2 goes into 4 2 times, right? You with me? So negative 3/2 x to the negative 7/4. However, I have to figure the slope at 1 2.
That's good then.
Well, but can I don't know. Is that the best derivative you can give me? What is the best f prime of x you can give me?
When x is in the denominator.
Okay, so what's it going to be?
Negative 3/2 over x to 7/4 to the x 7/4. Right? No, that's two things.
What root is it? Is it the 7th root or the 4th root?
Fourth root.
The 4th root
X to the 7.
of x to the 7th. That's the best derivative you can give me, okay? And then I want you to think about it. That's the equation for the slope of any point on that curve. I want to know the slope at 1 2. So what do I do now? That's our slope equation. That's not an official term. That's something we think of. And you said we're going to plug in 1, Caitlin? All right. Let's just seriously, the 4th root of 1 to the 7th. Yes, you do. What's 1 to the 7th power? What's 4th root of 1? 1. Yeah. So negative 3 over 2 times 1, which is negative 3/2. So daggone, we got the slope at 1 2. What's the equation going to be?
The tangent y minus 2 equals negative 3/2 over x. Times x minus 1.
1 and not 2.
Because negative 1 is in the pair above.
1 2 2 1. Yeah, you do. Why does the 1 have to be last?
Because that's an x.
Because it's an x. You had a brain fart. Sorry.
Okay.
Now, how are you going to write this? Your best answer.
The tangent equation.
The tangent line equation.
F of x at 1 2 is that.
Yeah. Right. That is the best answer you can give me. The best.
This has got so many.